After reviewing and editing TB data in program statistics, we move to the next objective, which is objective 3, model fitting. This model fitting occurs in the section indicators. Here we can either fit indicators or fit the model, and we can display indicators so that we can visualize the goodness of the fit. This evaluation of goodness of fit is discussed in the guidance document, in the annex of the guidance document. I will make a few remarks about this here also. Under fit indicators, we have a list of indicators we can fit, incidents, as well as a few types of incidents. These breakdowns are important for mortality calculations, as discussed before. And we can also fit to total notification, which is the basis of the costing projection. Notification and the split into case types is the basis of the costing work. So this is an important indicator for fitting. But the principle is the same for all of these indicators. We have an interface for each one that shows for us the number of cubic spline parameters, the number of bootstraps, and the smoothness penalty. The number of spline curves determine the flexibility of the model to fit data. If you have data that's very variable, we can increase the ability of the model to fit to this data by increasing the number of splines. But there is also a price to pay for making the model more flexible. We will come to that in a second. Bootstraps are the method of bootstrapping is used to create uncertainty intervals. Here we have a default value of 200. What this means is that 200 data sets will be created, introducing a variation for each of these 200, introducing a variation into the data so that effectively different models are fit to different data sets. And from that, we can determine a confidence interval using the 2.5 and 97.5 percentile, which forms the lower and the upper bound. The smoothness penalty is another parameter that controls the smoothness of the projection through the data. By increasing this value, we can force the model to be smooth, but if the data is very variable, the fit may not be good. So again, it's a compromise between fitting the data well and also producing a forward projection that is realistic. These values of 9, 200, and 0.05 has been determined through experimentation, and it fits most TB data very well for all countries. So for a first pass, we will simply use the default values. This interface here allows the user to select which indicator he wants to fit, but there is an option here which says fit all that can be used to simply fit all the indicators. So I'll press this now. It will then start to calculate total incidence. The calculation of the HIV positive split takes a bit longer. So while that happens, I will make a few other remarks. So now we fitted the incidence curve quickly, but the HIV split will take a bit of time because it's a more complex fitting procedure. We will go into that a little bit when the calculation is finished. By increasing the number of bootstraps, the user can basically create a better defined confidence interval. So that can be experimented too. However, the nature of the data over recent years is that the data themselves form a rather smooth curve. So the model is really able to fit the curve very well, and the confidence intervals are therefore very narrow. So in previous years, this played a bigger role to experiment, but in the recent years, given the smoothness of the data from WHO, uncertainty intervals is not playing such a big role. In the Appendix 3 for model fitting, there are some remarks about how to look at smoothness of the data and also confidence intervals and the role of, for example, of the smoothness penalty. Here we see now the fit to total incidence, and the curve is really, the data is very smooth, and the fit through the data is also very smooth. A typical result is that after the final year of data, which is 2019 this year, for this year's version of the model is the final year is 2019, we see that the confidence interval will typically increase a bit. So when we move outside of the data, there isn't something left to constrain the model. So in this period of time, the model will typically show an increase in uncertainty. Now, I can take this demonstration further by putting in a smaller smoothness penalty, and then we'll see that the confidence intervals will increase. I will do that in a second. I just want to make a note here about the HIV positive split. So this is all the data recorded in the country. We have data from Sentinel HIV settings in this case, and a survey point in 2011. So this survey point is really pulling the estimate towards the survey point because it carries a lot of weight. And this the HIV split, I just wanted to show that it has a few additional parameters, which are also explained in the appendix in Annex 3 of the guidance document. These parameters control the role of CD4 decline in the increased risk of TB. So there are 7 CD4 categories from the HIV model, and this regression model, or the statistical model that we've constructed here, uses those same 7 categories and constructs a function that controls how the risk for TB increases as CD4 decreases. And here we control the relative importance of the survey data and the Sentinel data and the routine testing data. So we're giving more weight to the survey data, which will typically lead to the curve going through the survey data in the years where we do have survey data. These principles are explained in the annex of the guidance document. And here is the fit to notification data. You can see here there's some more variation in the notification data. The incidence curve from WHO is constructed from data, and it has some smoothness properties already. The notification data is a bit more uncertain because this is based on actual data. So this data point here, which is much lower than the preceding years and the following years, is causing uncertainty here. And this is the reason why the uncertainty in the model grows so much after the final year. It's because of this variation in this data, data here. If we relax the smoothness, well, the fit to the data is already good because we can see that in this case, the 2019 point is actually well matched, and the curve, the projected curve is more or less just continuing on the same trend here. If we relaxed the smoothness penalty, we can refit the model for notification. In this case, it will fit the other indicators too. So I'll just give it a moment to complete. But what we will see is that the confidence interval, in this case, I was busy editing the notification parameter, not the others, just notification, because you can see here the title of the indicator I'm busy editing. So by relaxing the smoothness penalty, the models will be more flexible to fit the data, not just the data, but also the data sets that's created by the bootstrap process. So this in overall will produce a better fit to the data, but the price to pay for that is that there will be an increase in uncertainty. So that will complete in a few seconds. Okay. So here you can see how much more uncertainty we have now because of the relaxation of the smoothness penalty. If we increase again the value, then we will penalize this type of variation, and that will decrease again the uncertainty. So, and in this case, it's not just the confidence bounds which change, but it's actually showing an increase in the baseline notifications. And this can become important if you have an expectation that incidence is declining, and without doing anything extra, notifications is increasing. You may question whether that's likely to happen. It appears that the original value, the default value that was set when the smoothness penalty was 0.05 was more realistic. Just a smooth continuation of the trend seemed more realistic. But these are some of the factors you need to consider when fitting through data. And for most cases, the default parameters work just fine. So I will just refit the original one. While it's calculating, because we have 200, effectively 200 fitted models, we have the original data set and a curve fit through it. And then we have 200 bootstrap data sets created, and we fit curves through them. This gives us 200 potential models, and we can now choose what result we want. Currently, the default is to use the median of all of these 200 notification trends for our best fit. And that median will then be used for the rest of the calculations. I will go through that in a minute. And when it's finished, I will demonstrate some other choices one can also look at. Let's just give it a second here. Right, so now we're fitting total notification. Right, so now it's finished. So now if we see that the variation and the confidence intervals are reduced again because we increased the smoothness penalty. So we're penalizing variation. The other types of choices we can make is over here. We can use the median, the mean, the average, or the best fit. We recommend to use the median. But the user can also look what, and in many cases they are very similar. For example, here's the best fit. In other words, it's the closest possible fit to the data. But when we look at the median, we are now taking the median of 200 models to produce this projection here. So I'm now going to close this editor of fitting. For further technical information, the user can consult the guidance document. Annex 3 explains the fitting process in much more detail. We can now also look at display of indicators, similar to the one we've seen, but just focusing here on the visualization of particular through the data without the confidence intervals and the other elements. So here, as importantly, is the notification fit. As I just discussed, it's a fairly smooth projection through the data with a slight decrease, and it seems like a good fit to the data. We also have the incidence that we can look at. Again, it's a fairly smooth curve. The data itself is smooth, especially in the recent years, whereas notification is reported data. So in this case, for this country, there was a unusually low data point here, and there may be several reasons for that. There may have been some disruption in the notification process in 2017, and of course in 2020, we expect for many countries to see a decline in notifications due to the disruptions caused by the global COVID pandemic. I want to make the further remark of the role of incidence and notification projection. So there are now many places where we can see these projected results. So first of all, once the model has been fitted, if we go back to the program statistics, then that projected value will now be used here in this editor where the case types are split. We will now use the fitted model projection and redo the split. When you first entered this editor, you had a default projection here of notifications. That default projection is now replaced by the one just produced with the model fitting step. So that's where you will find that notification trend. So it's certainly very important to get a good fit and to review the direction of the fit. Is the relative increase or decrease realistic? This trend does look realistic, because if we're not doing any extra effort, the notification is going to stay roughly the same. And there's other places we can see these results. For example, I will review results further, but just as a demonstration, that incidence result that we produced with the model fitting will show here in the incidence results. I will show that in a minute. The model just has to do a calculation, which is taking a few seconds here. So I'll just give it a bit of time to complete here. Okay. So here we can see the total incidence as well as the split in HIV negative and HIV positive. So in this case, you can see that the model and the split for HIV is fairly well matching the WHO's own split. So in this case, we have a reasonably good split for HIV. We have a good projection of total incidence and a good projection of the split for HIV-TB. And this incidence result, as we will discuss later, is then used for the mortality calculation. So that concludes the model fitting process and the review process. And we will now continue to the next step, which is to produce the target populations using these model fits.